All right. Hopefully today's lesson is going to be just a reminder for you guys. You should have learned some of this either in Algebra 1 or Algebra 2. Just a reminder, a monomial is just an equation that only has one term. Like rather than having x squared plus 3x plus 27, you're just going to have one term where everything is being multiplied together. Like 2x squared, that's a monomial, or 2xy, or something like that. Okay, so we're going to look at the rules for multiplying and dividing monomials, which again, hopefully you already know. This will just be a reminder, but it's something that we have to go over before we can move on to what we're going to be doing next, which is multiplying and dividing polynomials. Okay, so the first thing to remember when multiplying terms with the same base, add the exponents. So for example, x squared times x cubed. These two terms have the same base. They both have a base of x. So when we multiply, the base stays the same, and then we add the exponents. So we get x to the 5th. Is this something that you guys already knew? Hopefully. Right. Remember learning it at some point? Okay. When dividing terms with the same base, subtract the exponents. Crazy. Okay, so let's say we have y to the 5th over y cubed. So y to the 5th divided by y cubed, those have the same base, and the base stays the same. And we subtract exponents. 5 minus 3 is 2. So we get y squared. All right, let's just look at some examples. Sure. You would just end up with a negative exponent. Yeah. Okay, here's example 1. 4cd times 5c cubed d to the 6th. Okay, so we're just going to take this one step at a time. We're going to multiply the coefficients first. So that's the 4 and the 5. And 4 times 5 is 20. Now we're going to multiply the c terms. c times c cubed. The base stays the same, so we still have a base of c, and then we add the exponents. So the exponent on this c, if there's not one, it's understood to be 1. So 1 plus 3 is 4. We get c to the 4th. And now we're going to look at the d terms. D times d to the 6th. We still have a base of d. And this d that doesn't have an exponent has understood to have an exponent of 1. 1 plus 6 is 7. Example 2. y to the 4th times y squared. So same thing here, we're going to multiply the coefficients first. We have 11, and when there's not a coefficient, it's understood to be 1. So 11 times 1 is 11. Y to the 4th times y squared is y to the 4 plus 2, which is 6. I'm going to write this one just with a multiplication symbol rather than with parentheses. It's worked the exact same way. I just wanted to show you it can be written either way. 2x squared times negative 6x cubed. Okay, so we work it the same way. Multiply the coefficients. 2 times negative 6 is negative 12. X squared times x cubed is x, and 2 plus 3 is 5, so it's x to the 5th. Most common mistake is multiplying the exponents rather than adding them, so be careful there. All right, one more. W to the 5th z squared times negative 9 w squared z to the 5th. All right, multiply coefficients. The coefficient in our first monomial is just 1. So 1 times negative 9 is negative 9. W to the 5th times w squared. The base stays the same, and we add exponents. 5 plus 2 is 7. Z squared times z to the 5th. The base of z stays the same, and we add exponents. 2 plus 5 is 7. I think I said that was going to be the last one, but I lied. There's one more for multiplication. Five x to the 10th times 10x to the 9th times negative 5x to the 6th. So the only difference here is that now we're multiplying 3 monomials rather than just 2. we work it the exact same way. So we're going to multiply all of the coefficients. 5 times 10 is 50, times -5 is negative 250. X to the 10th times x to the 9th times x to the 6th. So our base of x stays the same, and we add all the exponents. 10 plus 9 plus 6 is 25. Okay, we're going to keep going with examples, but now we're going to change gears and do division. Six x to the 4th divided by 3x squared. So divide the coefficients first. 6 divided by 3 is 2. X to the 4th divided by x squared. The base stays the same, so it's still x. And when you divide, you subtract the exponent. So 4 minus 2 is 2. We get 2x squared as our answer. Negative 8x to the 7th divided by 2x cubed. Negative 8 divided by 2 is negative 4. And x to the 7th divided by x cubed. The base stays the same, and we subtract exponents. 7 minus 3 is 4. We get x to the 4th. X cubed y to the 5th divided by x to the 5th y cubed. Okay, there's no coefficients. Actually, both of the coefficients are 1, and 1 divided by 1 is 1. We're not going to write that. So when we divide x cubed divided by x to the 5th, the base of x stays the same, and we subtract exponents. 3 minus 5 is negative 2. So it's okay to have a negative exponent. That can happen. Then y to the 5th divided by y cubed is y to the 5 minus 3, which is 2. Sixteen x cubed divided by 10x. All right, divide the coefficients. 16 divided by 10. That's not going to give us a whole number answer. And I don't want us to write a decimal. So instead, I just want you to simplify the fraction. So 16 over 10 can simplify to 8 over 5. So 8/5 is our new coefficient. Huh? Just don't like them. All right, x cubed divided by x. The base stays the same, so we still have a base of x. And the coefficient on this x in the denominator, or the exponent, sorry, is understood to be 1. So 3 minus 1 is 2. Last one. Fifteen x to the 4th divided by 25 x squared y to the 5th. Okay, 15 over 25. We just need to simplify that fraction. That will simplify to 3/5. X to the 4th divided by x squared. We have a base of x. 4 minus 2 is 2. Now our y terms, we don't have a y in the numerator. So the way that you can think about it, what is y to the 0 power? It's 1. Anything to the 0 power is 1. So it's not going to mess this, we're not going to change the value of this fraction if we just wrote in y to the 0 in the numerator. We're basically just multiplying that numerator by 1, which doesn't change anything. So we're allowed to do that. And now we can see when we divide the y terms and subtract the exponents, 0 minus 5 is -5. Yes. Mm-hmm. Well, and there's another rule in math that if I were to move this x squared, if I wanted to move it to the numerator, I can do that. I just have to make that exponent negative. It's the same if I have something in the numerator that I want to move to the denominator. I can do that. It just changes the sign of the exponent. So this would be 1 over 4x to the -3. Anytime you move a term to the numerator or denominator or vice versa, it changes the sign of the exponent. So you can think about what we did as just moving this y term to the numerator, and it makes that exponent negative. Or you can think about it exactly how we worked it, where you're just subtracting from an exponent of 0. Okay, let me get your assignment posted on Google Classroom, and you guys will be able to get started on that.